Hey GED students, it's GED question of the day time, and today we've been asked to determine whether each of the following numbers is divisible by 11. So one of the most important topics to teach GED students is the topic of divisibility, and it's also one that too many teachers skip over. Okay, a few reasons why. First of all, divisibility problems in many different forms, okay, can show up in the first 5 problems of the GED, the ones where you don't get a calculator. So you might see factors, multiples, greatest common factor, least common multiple, reducing fractions. All of those things hinge on the concept of divisibility. Okay, so that comes up in its own right. But then second of all, divisibility is a really key concept that unlocks a lot of other skills, such as doing fractions or factoring later in math, working with algebra. So divisibility is just going to help us in so many ways. It's like your math superpower. So I have a problem, though, with students in that they make assumptions that aren't always true. And what students always end up assuming about the 11s is that if you see a number repeating, it's got an 11 in it. And I get why. Because when you first start your 11 times tables, 11, 22, 33, 44, for a while there, it looks like 11s always have this repetition going on. But I want you to notice something about 11 times 10. 11 times 10, of course, if you multiplied 11 times 10, it would just be an 11 with a 0 on its butt. We do kind of see that repetition of 1, 1, and then a 0. But then after that, if you were to add another 11, like 11 times 11, let's try it. You might not have that one memorized, so I'm going to add 11 to see what the next times table fact about 11 would be. And you can see this concept of things repeating kind of stops. Now I have 121. The next thing on my 11 times tables is 132. So this is my fair warning to you. Looking for those repeating digits only works for 2-digit numbers. So like, for example, I can easily tell that 88 is divisible by 11. It's on the 11 times tables because of that 2-digit repeating numbers. And I can easily tell that 74 is not divisible by 11 because I don't see that repetition of the 2 digits like 77 or 44. Okay. However, I can't tell with larger numbers. Like 222, it's bigger than 2 digits. It has 3 digits. I can't tell if it's divisible by 11 until I divide. Guys, it's not that hard to divide by 11. I'll just go ahead and use long division or sight division, short division, but use a division method to see if 11 goes perfectly into 222. So let's see, 11 goes into 22 2 times. That is 22. Subtract that out, and all I have left is a 2. Of course, 11 doesn't go into 2 at all, and so I end up with this remainder of 2 that I have not used up. A remainder, and things are not divisible. 222 is not on the 11 times tables. Okay, so the basic rule here then is if you have something that's more than 2 digits and you want to check for an 11, just go ahead and divide. Okay, let's check it out here. 11 goes into 37 3 times, of course, that'd be 33. Subtract that out, I get a 4, drop a 4, and now it's easy to see. 11 goes into 44 perfectly, of course, with that repeated. No remainder at all. And I am done. 11 went into 374 perfectly with no remainder. Therefore, 374 is divisible by 11. This guy is, yes, divisible by 11. And then for 4076, same thing. It's more than 2 digits. I better divide to check. 11 goes into 43 times. That's 33. I get a remainder of 7. Drop the next digit, 77. Ooh, it goes perfectly into 77. This is looking promising. 11 times 7 is, of course, 77. None of that will be left. I'll drop my 6. 11 does not go into 6, and I end up with that 6 remainder. There's that 6 I have not been able to use up. I have a remainder. 4076 is not divisible by 11. That's not on the 11 times tables. All right, so I have 2 numbers here that are divisible by 11, 88 and 374. Wonderful. If you have any questions about this or any other GED topic, be sure to drop it in the comments, and I'll do my best to answer it.